are watching this, you're probably already aware that our bodies are made up of cells. And you probably also know that many cells with unique functions, different abilities, will often work together to accomplish a larger goal. And when these cells with these specialized but cooperating functions do this, we call those cells working together in a system. So you probably think of things like the respiratory system or the cardiovascular system, but maybe the immune system comes to mind. And if it does, you probably already know that the immune system is responsible for protecting us against disease. But how does it do that? Right? Because you think of the respiratory system, that's your lungs. The cardiovascular system is made up of our heart, our veins, and our arteries. But what is the immune system made up of? I mean, the only organ you might think of is the spleen. So, what is the immune system and how does it work? Hello, my name is Shelby Bradford and I'm the Geeky Goth. Today, we're going to scratch the surface of my favorite set of cells, those in the immune system. Now, what do I mean by my favorite set of cells? Well, I got my bachelor's degree in immunology and microbiology. Then I chose to do more school and am currently a graduate student pursuing a PhD in these same fields. I've taken a lot of coursework on the immune system and microbes, but I've also taken courses in genetics, vaccines, and cancer, and the immune system is involved in each of these topics. Today, however, we're just going to focus on introducing the system, who's involved, and how it works in an overview, and we can get into the more complex stuff another day. For now, let's just focus on the big picture. Let's familiarize ourselves with this family, and we can get into each member's dirty laundry another day. So, without further ado, and what better place to start than with some introductions? For this video, we're just going to focus on two main groups of players in the immune system, cells and proteins. We can get into more details in the future. Now, we also usually divide the immune system into two groups or arms based on how these players and parts work. These arms are the innate immune system and the adaptive immune system. This distinction is going to help us think about and understand the jobs these cells will have and the mechanisms they're going to use to complete them. Members of our innate immune system are able to respond rapidly to microbes or other unfamiliar or potentially dangerous agents. However, they do so non-specifically, so every encounter is like the first encounter. Meanwhile, our adaptive immune system must train itself against each new agent and so takes longer to show up. However, once it learns this agent, it forms a memory, and so the second encounter is much faster than the first. Alright, now that we've gotten our preview out of the way, let's get into some specific characters. The innate immune system squad has a very robust cast, and almost like a big family, we could really go down a rabbit hole trying to explain every single member and everything they do. So for this video, I'm just going to focus on the biggest players and their primary jobs. When we do this, we can really split these cells into two distinct types of jobs. Those that are phagocytes and those that are granulocytes. So let's look at each of these and the cells that are involved. Phagocytes are cells that are going to eat things. That's what the first part of the name is referring to, the act of eating or consuming. Now this might sound like a silly task for a cell to have, but it's actually an important job that is vital to the immune system, since this is going to be the mechanism that cells use to get rid of pathogens or other debris that might be floating around our body. It's also going to be important for some of the functions that we'll look at in future videos. Our phagocytes are neutrophils, macrophages, and dendritic cells. Now, each of these cells has other functions, some of which we'll touch on in this video, but most of which we're going to save for their own dedicated videos in the future. Today, let's look at that other type of cell job. This second job type involves cells that we classify as granulocytes, or cells that have granules. I know, very clever, but these are important jobs, again, just like our big eating cells, the phagocytes. Our granulocytes are mast cells, basophils, eosinophils, and yes, neutrophils. Turns out when eating the bad guys doesn't quite get the job done, these guys will pull out some heavier artillery. And fun fact, if that still doesn't work, these neutrophils have a tendency to just explode. But since cells going boom is more of a last resort, let's talk about these granules. They have a lot of different functions, more than we can discuss here. But some general ones are some of these proteins and chemicals are going to be responsible for killing these selected organisms or other targets. But another very important function of some of these granulocytes, specifically a group of proteins that we call cytokines, which actually many of our phagocytes also produce, is to induce inflammation. Inflammation is really the main mechanism that our immune system is going to use to activate and then respond to some danger, whether that's an infection or a cancerous cell, or if it's something we've eaten that we really shouldn't have. It is initiated by those proteins, the granules, cytokines, and other chemicals and compounds released by our cells that cause physiological changes in our bodies. There are 4 hallmark characteristics of inflammation in a healthy immune response. Those are fever, pain, swelling, and redness. And as awful as all of those sound, it gets better. Take a look at the rest of the responses attributed to this inflammation and the activation of our immune response. You'll probably start to notice that all of those miserable symptoms you associate with the cold are actually the responsibility of our immune systems defending us. Oops. It may be hard to believe that any of this has a benefit, but believe it or not, it's all intentional. However, these inflammatory responses are complicated, and it's going to take us some time to break them down. So we'll go into them in detail in a future video. So far, we've introduced a lot of different cells, and all of them have a variety of functions and are going to produce proteins or other molecules that are going to drive inflammation, this mechanism that the immune system uses to really get things done. However, there's one other source of inflammation on the innate immune side, but it doesn't come from a cell. Instead, it's a highly organized compilation of proteins that we collectively call complement. The complement is so fascinating that it's going to get its own video just to discuss it in the detail that it deserves. However, I will give you this little sneak peek. These complement proteins are going to act like tiny grenades, traveling the body at all times, ready to pop off at a moment's notice and signal trouble. And their main job is to drive fever and destroy pathogens. So those are our non-specific innate immune responses for this overview. But what if we want something a little less generic? Something that's going to pack a punch and remember for next time. For that, we're going to need our adaptive immune system. The adaptive immune system has less components than the innate immune system did, at least for as detailed as we're going to get into today. This arm of the immune system is responsible for the long-term protection that allows it to respond faster and more efficiently if it ever sees the same agent again. However, this immunological memory requires some more specific mechanisms than just riling everything up, which is why activating B and T cells, the hallmark of our adaptive immune system, takes longer than the cells of our innate immune system. Once these cells are primed though, they and their respective proteins may stick around for a lifetime. These proteins include antibodies produced by B cells, while T cells are responsible for a multitude of cytokines and in some instances, granules like we saw in the innate immune system. Now, there is one last major player in our lineup for today, but it tends to be a bit of an oddball. It's called the natural killer cell, and this cell grew up from the same group of cells as our B and T cells, but it operates more like an innate immune cell because it doesn't learn specific agents in the same way that our B and T cells do. However, it doesn't fit into the role of either a phagocyte or a granulocyte like the rest of our innate immune cells. Instead, NK cells patrol our own cells, looking for imposters using a special ID marker. If it finds an imposter, it will signal our own cells to die. Yeah, the immune system is kind of metal AF. And that concludes our introduction to our main members of our immune system family. Now that we're cozy with who's who and where everyone falls on the family tree, we can get into more details of each member in future videos. But before we end here on this overview, it might be a good idea to talk about how the immune system actually wraps up its immune response. As inconvenient as the runny nose or the feverish skin is to our day-to-day life, they are unfortunate consequences of the very important efforts the immune system puts in to keep us, alive. It's mediated by all of these proteins and chemicals, molecules, compounds, cells, and is driven by this mechanism we've called inflammation. Inflammation is the gas pedal to the immune system. But what about when the job is done? Lucky for us, this system comes with brakes. You see, once things get a little too heated or the all clear signal is thrown to say there's nothing left to fight, specialized types of macrophages and T cells and even non-immune cells like nerve cells or fat cells release proteins, hormones, and other molecules and compounds that are going to instruct all of these cells producing all of these other proteins and molecules to drive inflammation, tell them to pack it up and go home. We cleverly have called these proteins, cytokines, and molecules that reduce inflammation anti-inflammatory. Then the healing begins. No joke, the site of an immune response is a battlefield, and our own cells take a beating. Thankfully, these specialized cells that produce these anti-inflammatory molecules are also going to help clean up the damage from this fight and promote cells to grow to replenish the ones that were lost. There is so much more to the immune system. Interactions, functions, activities, cell types. It's a mesmerizing thing. But let's not get ahead of ourselves and get overwhelmed all at once. Now that we have our bearings, let's stop here and we can pick up on more immuno adventures in a future video. If you've enjoyed exploring this topic today, like and subscribe to join me the next time we talk about more awesome science.